All right, what I have up here is instrument approach chart, and they're published for all aerodromes everywhere, provided they have some allowance for an instrument approach. There are two basic instrument approaches to aerodromes or airports, and one, it's non-precision or precision. Now, precision approach is where you have the radio navigation instrument landing system, or ILS, which is very accurate, and it can bring you right down to the end of the runway without having to, like, fully automatically. It controls the, or it tells you whether you're too high, too low, or too much to the left, too much to the right. A non-precision approach is either the old-fashioned way of coming in on a non-directional beacon, which is just a normal radio beacon, like a marine beacon, only at the airport, or the VOR radio navigation, which will get you into the proximity of the airport, and that works by like spokes on a wheel. The radio navigation doesn't just tell you what direction the station's at, it tells you what degree or angle you are from it. So it can allow you to follow a fixed radial in or away from the radio station. Say you can tune it into 270 degrees, and it'll tell you whether you're going off to the left or right of it, whether you're flying towards or away from the station. All of those non-precision approaches demand that you have to break out of the clouds at a sufficiently high altitude that you can now visually land the airplane at the runway. Whereas a precision approach, it's more or less the same, but it allows you to go way closer to the ground before you break out of the clouds. So on this approach plate here for Victoria, there's Victoria Airport, only for landing on runway 09. Right at the bottom here, it shows if you're landing on the ILS system, you can be 305 feet above sea level, indicated. If you're coming in on one of the non-precision approaches, then it's going to be much higher than that. For a localizer DME, which is the same as an ILS, except it doesn't really tell you your height. You have to figure that out yourself using the altimeter. So you have to break out of the cloud a little higher. A circling approach, where you're actually visually breaking out and looking for the airport, you have to be even higher still. 600, it all depends on the other variables. Now on the approach, there are different waypoints that are usually identified by the modern GPS. So at runway 09, you have this waypoint. You have to be at 4,000 feet to be there because of the hills. Once you get to this waypoint, you can start descending down. You're at 3,600 feet. You can descend down towards 2,300 by the time you reach this one. At 1,400 feet, you're at the Mill Bay non-directional beacon, which is right in line with the runway in this particular case, across the bay on the land from the threshold of runway 09. And then from there, you're down to a landing. So a precision instrument approach will take you down this without you having to calculate and determine and make the airplane go to those certain altitudes. The instrument approach system, if you follow it, will automatically take you down that glide path. The one example, using the older style instruments, you manually fly the airplane following the needles to tell you whether you're left, right, or up and down. On modern systems, it's connected with the autopilot, which will make the plane do it automatically. So, straight up and down view, Victoria Airport, Mill Bay non-directional beacon, and all the corresponding waypoints that are on this chart. It gives the frequency for the non-directional beacon, which we'll have the plane tuned into. Up here it gives the frequency for the instrument landing system, 108.7, and all the other information, including a look at the terrain. Now this line, if you make a missed approach, for whatever reason you don't break out of the cloud, or you don't see the airport when you do, or the clouds are lower than the limits allow, you do a missed approach and you continue climbing up, following this track, and eventually aiming for the non-directional beacon at active pass, which is also used for marine use. And there's the frequency and the Morse code identifier. So that's how the basics of an instrument approach chart. This, of course, you understand very well before you even try to make a landing at the airport. So with that in mind, let's give it a try. We are northwest of Victoria Airport, CYYJ. So we're north of the Mill Bay non-directional beacon, or NDB, and we're trying to pick up the instrument landing system, the ILS, which is south of us, and then we can fly due east to line up with the ILS runway 09. We're in a Cessna 150, which has the, I guess the best way to put it is pre-GPS instruments, basic instruments that date back decades. So what we have is the non-directional beacon finder, which is called an automatic direction finder. They've been around since before the Second World War, and they'll point at any medium band or low band AM transmitter, non-directional beacon, like a marine beacon, like up in Active Pass or Mill Bay, or AM broadcasting stations even. This will point to it, and that's all it does. So it'll point to it, and from there you have to figure out where you are, and without any other information, you don't know how far you are from the beacon. The other thing you have is the standard VOR, which is a device that will pick up a specific radio transmitting station that provides beams of radio signals that are like spokes of a wheel. So if you tune in to which radial around the compass you want, if that needle centers, then you're on that radial or spoke of the wheel. And as long as you keep that centered, you will fly either towards or away from that transmitting station. And this little arrow here means towards, or if it's below, means away. This horizontal line is an added feature on this, which gives you the vertical positioning on approach. So this is the ILS, or Instrument Landing System, and it will give you a precision approach to landing at the airport. It'll bring you down to, depending on the airport, down to several hundred feet off the ground. It all depends on the airport. That information is provided on the instrument approach chart, which I've shown at the beginning of this video. So between these two instruments, we can get set up and land within a couple of hundred feet of the airport. Now, if we don't clear the cloud by the time we get down to the minimum altitude as posted on the chart, then we have to pull up and go around and go somewhere else. But I have it set up so that we're within minimums and we should be able to do a proper landing. All the other instruments are pretty standard. The VSI, vertical speed indicator, altimeter, the artificial horizon, which obviously if you can't see anything out the window, that's your horizon now. Airspeed indicator, and the gyro compass, which will point to whatever you set it at, no matter where you turn the airplane. So, as always, you would set it to the magnetic compass when you're either stationary or straight and level flying. And that way it gives an accurate reading during turns, whereas this will accelerate and spin during turns or climbs or descents. Turn of bank indicator, very important to tell you what degree of angle of bank. In instrument flying, most of the turns are done with a 2-minute turn, which is with the airplane down to there, the wing down to about there. That's about 20 degrees. And that'll give you a complete turn at any speed, doesn't matter, in 2 minutes, or 180-degree turn in 1 minute. So let's get started. Once again, we are northwest of the airport, so we're going to swing south, and this little tip of the arrow is pointing to the non-directional beacon at Mill Bay right now. With the chart, you can see where that is. It's across the water to the west of the airport. So we're going to have it straight up and down, and that means we're flying straight to it. Okay, so away we go. So we're now flying. We're currently 1,400 feet. Now remember, the VSI responds in a lagging fashion to what the plane's actually doing. So you have to be patient, let it flop around, look at the altimeter, and decide if you're going up or down. So on instrument flying, you have to be pretty quick on the controls. See, I'm letting it descend there. So I pitched it up. I've got a slight right turn on with the artificial horizon. The airspeed is good, but it's a little quick. It'll come down. And we're stabilized at the altitude. There's the ADF, so we're swinging a little to the right of the beacon. So we'll turn to the left and get that lined up. Now the whole trick is, when you're going in the right direction, make sure you level the aircraft. And any turns you make, try to do them before you line up with where you want to go. So we're just trying to stabilize the aircraft here. Bit of a slight right turn to get straight at the NDB. Now as you approach the NDB, it's unlikely you'll go straight over it. So the needle, one way or the other, will swing to the right or left, and you can see it going there now. So we're now in transit over the NDB. This vertical needle is indicating that we're right in line with the runway. So we've already made our turn to the east, and we're going a little to the left of east. So we'll bring it over to the right of east to get that needle centered. Once we get it centered, we go back to east, because east is straight towards the runway. Our altitude is good. This horizontal line indicates our position up or down from the preferred glide slope. So we're right bang on up and down, but we're a little to the right. So we're going to turn a bit to the left to line up. You'll end up chasing the needles, which is a bad thing. You try to not do that, or else you'll be oscillating up and down and left and right all the way down. Yeah, it's hard to do. So the plane responds quickly, and you have to be right on top of it. Now, while you're doing that, watch your airspeed. You're doing your scan of the instruments. We're generally headed in the right direction. So all I'm trying to do now is keep this centered there. Now, we're getting down to our minimum altitude, and already we can see the strobes at the threshold of runway 09. So now we've broken through. We're at legal minimum limits, so we're above minimums. So now we can do a visual approach and line up with the runway. Now visually, you've got a lot more accuracy in aiming the aircraft than following the instruments. It's like following a compass through the bush. You don't just stare at the compass. But if you're on instrument flying, you have no choice. If you're visual flying, you can look for a landmark way off beyond the airplane. So we're on visual now. Notice that we're above the slope, and the VASI lights, which are both white, indicate that we're above the glide slope. If we get one white and one red right there, that means we're right on the glide slope, and there's the line to prove it. So we're right straight on, and we're at the right altitude. So now we're varying the throttle to vary our descent rate. We've got 20 degrees flaps out for normal landing. All this time we've had the carb heat out, which is proper. Airspeed's good. And you just fly it down to the runway. So now it's just a normal visual flight. Now keep in mind that we didn't have any communication with air traffic control, which is not normal. You can't do this without communicating with air traffic control, because they're the ones that keep you clear of other traffic. They're the ones that suggest or tell you what you should be doing, which way to point the plane, which altitude to fly. For this video, we've just concentrated on the actual procedure on the assumption that air traffic control has been telling us what to do.